Oh yeah, welcome there. Plenty of room over here at the GameDev Tavern. Just make yourself at home as we build fun little games together. My name is Nicholas, and this is episode 5 of the tutorial series where we create an arcade 2D soccer game from scratch in Godot. And welcome back. Over the last few episodes, we've been laying out a solid foundation for our player and for our soccer ball. So today we'll be able to leverage that foundation to start implementing some core gameplay elements. So first of all, we'll start off by polishing our carried state. As of now, the ball kind of feels awkward, just stuck over to the player's feet. Doesn't animate at all. We're just going to go ahead and fix this. So we are going to be placing the ball, depending on whether the player is facing towards the left or towards the right, with about an offset of about 10-15 pixels off from the player. We're going to just try to see what feels best. So let's start by creating an exported variable that we can tweak and play with in order to find what works well. So let's hop over into our ball. Let's go into the script, and here let's create an exported variable. Let's call this offset from player. We'll make this a vector2. Now let's go ahead and use this variable here. So when we go into the ball state carried, rather than just stick it at the feet of the carrier's position, we're going to offset it. Now we want to make sure that we take in consideration the way that the character is facing. So if we are facing right or left, heading.x is either going to be equal to 1 or minus 1. So then let's go ahead and use this new property, and then vertically I think we can just use the offset.y. All right, so let's go ahead and try it out, and I'm going to focus on the ball here, and we're going to be playing around with these properties. So I'm going to go into the carried state, and let's try 5 and 5, see how that feels. Going back to the game. Okay, and you can see that how it offsets it from the feet. This already looks a little bit better. I do think that the ball is a little bit too far down and not enough to the side. So let's try something along the lines of 10 and 4. All right, and this is already looking a lot better, kind of feels a lot more dynamic. So we're going to use those two values. However, I actually don't want this offset from player to be part of ball. This is great when you want to just tweak things and play test them and find what those values are. But actually, like, the ball itself doesn't really need to know about the offset from player. That's the whole purpose behind us using a node state-based machine, is that the information that's tied to a state should really be self-contained within that state. So rather than have that property here, now that we have found the values, I'm just going to promote this property to a constant, and we're going to include that as part of the carried state. So let me hop over into the carried state. I'm going to create a constant here, and we're going to call this offset from player, just in all capital. And here we mentioned that we were going to be using 10 and 4. Then I'll just be replacing the variable inside my code. All right, and that should do exactly the same thing. Let's just try it out. Okay, perfect. All right, so now we just need to play the proper animation. So we'll want the ball to play the idle animation whenever the player is completely static. So basically when the velocity is 0. And we'll want it to roll whenever the velocity is not 0. So let's go ahead and add this as part of our process method here. If the carrier's velocity is different than 0, we'll go ahead and play our roll animation. Otherwise, we'll play our idle animation. All right, it's complaining here because we don't have access to animation player. It is still a property from the ball. So let's hop over here. We need to have a reference to the animation player. So similarly to what we did with the player detection area, I'm going to right click on this animation player, access as unique name, and we're going to create an unready variable here. All right, and you could self-type it, or you could just drag it here. It's about the same. And because this is the dependency, we'll want to pass this and inject it as part of our setup so that all of these states have direct access to it, and there's no dependency between the ball and the animation player. So let's go ahead and add it here. And we're going to hop over into the setup, and we'll need to include it. and as the last argument here. I'm hoping that this is starting to make a little bit of sense. Basically, once again, the main thing we're trying to do here is to pass. Let's see, what's the problem here? Context player detection area is not. Oh, there we go. We want all of the state objects to be able to access not only the main parent, but also all of the parent's dependencies directly. Okay, so now that we have the animation player, let's just make sure that these errors go away. Let's go ahead and try it out. All right, so you can see that we are now playing the correct animation when we're going left or right, and when we stop moving, it plays the idle animation. The only thing that's a little bit weird here is that when I'm facing right and running towards the right, it looks like the animation is correct, but when I'm running left, the animation seems a little bit backwards. And we should probably place the animation backwards when we are running towards the left. Let's go ahead and fix this real quick. So whenever we are rolling here, let's just check whether we are facing right or left. So if we are facing, let's start with right, we'll go ahead and play roll. Otherwise, we'll play it backwards. All right, let's try this out. All right, this is working well. Semi-working well. It worked a little bit, and then it completely stopped working. It seems to be very inconsistent. My guess is that we're trying to play the same animation, and maybe the animation player gets confused if we're asking it to play this animation when it's at the last frame and when we're asking it to play backwards when it's at the first frame. This is something that I've seen happen from time to time. I'm not sure why, but the loop property just doesn't necessarily trigger automatically. So there's a way that we can force Godot to move forward to the next frame. We can do this using a method called advance. And we'll just make it advance by 0 second. You can look at the documentation here. It just manually advances the animation. And we'll do this for the play backwards as well. Let's just see if this works better. All right. Okay, this looks a lot better. We'll probably get rid of the shadow, by the way, when the ball is on the ground, but we can do that later. Okay, it still feels a little bit static. I don't know about you, but the ball shouldn't quite stay at the same distance as the player. Whenever the player moves and runs, we should probably have some additional movement on the ball, just little taps and so forth. So this almost seems like a good opportunity for a little creative challenge. All right, so here's the challenge. Rather than have the ball stay at a fixed offset from the player, try to find a way to add some slight variation to the movement so that it just feels a little bit more natural and dynamic. I'm calling this a creative challenge because there's actually no right answer here. It really depends on what you want to build and on the behavior you want the ball to have. So maybe it'll be adding some randomness, maybe some form of bounciness, elasticity, I don't know. But I'm actually curious to see what solution you might be coming up with. So go ahead and pause the video right now and then see what you can come up with, and then we can compare our solutions right after this. All right, well, hopefully you took the time to try to complete the challenge. And if not, that's perfectly okay as well. On my end, I have decided to go with a very simple oscillation that I added on top of the ball's movement. So it's really quite straightforward. It just adds a little nice touch of polish. So basically, as the player runs, I'll have the ball, I'll just add an additional variable here that just goes back and forth on the x-axis, and it just will provide a little bit more dynamicity to the ball. So let me just show you how I implemented this. So I'm going to hop over into my script and go into the state carried. And so here I want to update the ball's position. I'm going to add a new variable. Let me call this variation x, and I'll set this to 0.0 for now. And I can just add it right away to my position, but I'm actually going to be modifying Vx whenever we are moving, so as part of this if condition here. So rather than have the ball's position line here, I'm just going to bring it down so we can update the position after we have modified Vx. So the main thing for Vx is I'm just going to have a cosinus function here. So I'm going to say that Vx equals cosinus. And here we're probably going to need a couple of things. First, let's have some form of dribble frequency. And we'll make it as part of the ball to start with. So that way we can play around with it to see what works well. And we'll multiply that by the dribble intensity. Let me go ahead and create those two variables as part of the ball. We'll export them so we can play around with them. So we have a dribble frequency, which is going to be a float, and a dribble intensity, which is also going to be a float. So this is how often the ball oscillates, and this is how far the ball oscillates. So going back here, this is, if I just leave it like that, Vx is always going to be the same value, so it's not going to do any sort of oscillation. I need to have a form of time in here. So basically I need to multiply this by time, and I'm going to be using this delta here to do that. So just to keep track of time, let me create a class variable. Let's call this dribble time. We'll start it at 0, and we'll just add delta to this time here. Okay, and then let me just multiply this by our dribble frequency. All right, so I'm just going to pause for a second here. So once again, I'm just adding to my horizontal position this value Vx, and the value Vx basically oscillates throughout time with a certain frequency. There's a time factor here, which means that this will continue to oscillate between -1 and 1. This is the value for every single cosinus, and then we'll multiply it by the dribble intensity to just have a different type of magnitude for the oscillation. All right, so let's go ahead and try this out, and I'm going to hop over and focus on the ball here, and we're going to be playing around with, let me take it here. We're going to be playing around with the values for our frequency and our intensity. Let's go ahead and start with 5 and 5. So let me hop over into the varied state. Okay, and you can see here the oscillation, how it goes back and forth. I feel that the frequency is definitely not high enough, like this just feels slow. And then the intensity almost feels too much, like the ball is almost catching back to the middle of the player. So let me try frequency, I'm going to say 10, and then for intensity, I'm going to try 3. All right, and this already feels a lot better. You can almost feel that the ball is bouncing back to the player, but it never really leaves the feet. It just feels like the player is constantly hitting the ball. So this looks perfect. Once again, I really don't want those variables to be part of ball. There's not, the ball doesn't care and shouldn't have to care about those things. So I'm going to promote them. So I'm going to just remember we have 10 for frequency and 3 for intensity. I'm going to remove that and create 2 const instead. So into the carried state, go to the top, and here I'm going to call 1 dribble frequency. Here we mentioned this was 10, and a dribble intensity, and we set that to 3. So let me just replace my ball's properties here. All right, and we should now have the same thing here. There we go. All right, great. Well, it looks like the carried state is pretty much done. Oh, I do think that this is a little bit odd that the oscillation still happens when the player moves up or down. So we can probably just fix this real quick. So we only want to affect this Vx whenever we are not moving up or down. So I guess if carrier's velocity dot x is different than 0, then go ahead and implement this. Let's double check. If we move up or down, it doesn't oscillate. If we move left and right, it performs the oscillation. Okay, perfect. All right, well, this looks pretty great. What we usually do when something looks great, we just perform a checkpoint. So let me hop over into Git. Added, let's see, carried state with oscillation. Okay, perfect. So with our carried state properly implemented, we're going to work a little bit more on our soccer player and give them the ability to actually kick the ball. So for that, we're going to be creating 2 states. One is going to be used for preparing and powering up the shot, and another state is going to be used to actually shoot the ball. So we can start by adding the animations, and then we'll start adding the states right after that. So let's hop over into the 2D view, focus on the player, pick the animation player, and then let's go ahead and create a new animation. Bring this to the middle here. Let's call this prep kick. This is going to be a single frame animation, so I'm going to make this 0.1. I'm going to make it loop, and let's set the snap to 0.1 as well. Focus on frame number 0, pick the sprite, and then look at frame 48, and then you can insert a keyframe here. All right, this is going to be it for this one. And then let's create another animation. Let's call this one kick. And this one is going to be a lot faster, so we're going to have 3 frames. Let's snap them at 0.05. It's not going to loop, but it's going to total 0.15 seconds. And then pick the player sprite, and starting at frame 49, just go ahead and click on create, and then go all the way to frame 51, I believe. Yep. Okay, great. So now that we have animation set up, I just want to talk a little bit about shooting and how shooting is going to work. Shooting is going to be one of the most important game mechanics, so I do want to spend a minute or two just thinking through how we're going to build this new mechanic. So while the player prepares to shoot, there are 2 main components that we want to compute. The first one is the power of the shot, and the second one being the direction of the shot. And because we're using a very simple control scheme on the keyboard with just 4 directional keys and then 1 button to shoot, we need to be pretty smart here if we don't want the game to feel too simplistic. So we're going to be doing a tiny bit of math in this section, and don't worry if things don't click right away. So first, let's talk a little bit about the shot power or shot intensity. By default, every character is going to come with their own personal power stat, which will directly translate to the speed of the ball when the ball is shot. So for example here, we have a player that has a power stat of 80, which means that the ball would be traveling at 80 pixels per second. I think for Mbappe and Messi, I might have set a power of 100 or something like that. We can tweak those things down the line, and that just creates more fun when you play with different players. However, we could also be rewarding the players who take the time to power up their shots at the risk of being tackled while being so. The players stand still when they prepare their shots, and so the longer they wait, the riskier it is, and so the more powerful the shot should be. Now, this opens up a lot of possibilities in terms of gameplay, and the main question we want to ask ourselves is, what is the best way to reward the player for their patience? So one simple way would be to use something along the lines of a straight linear interpolation. Basically, the reward would scale up linearly over time. And to compute this, we could either use the lerp function or the easing function with a factor of 1. Then we can look at the time that's elapsed. Let's say that we look at that period over a period of 1 second. We then look at the associated bonus. For example, if a player has a base power of 80 and prepares the shot for half a second, they're going to get a bonus of 0.5. And we can apply that to our formula, which will create a resulting power of 80 times 1.5, which would be 120 pixels per second. And the nice thing about this easing function here is that we can play along with that property and figure out whether we want to have more or less dramatic effects. For example here, if we have an easing factor of 4, I am bending that bonus curve to reward those who are more patient while shooting. Meaning here that if you wait 0.5 seconds, you'll only get a slight bonus of about 0.05, but if you wait 0.8 or 0.9 seconds, you almost get the full bonus. The opposite example, if I bend the curve backwards, is what I like to call the French socialist curve, meaning that you can work like crazy, or you can just work a little bit and you'll pretty much get the same reward. Anyways, so I'm personally inclined to favor rewarding the risk, so I'm going to be picking an easing factor of 2. So it doesn't penalize players too much for trying to play fast. And, this is an arcade game after all. But you should definitely feel free to play around with those values on your end and just pick something that you think fits the game best. All right, so now that we figured out how to implement the power of the shot, we're going to talk a little bit about the direction of the shot. So most likely, at some point, we will be implementing gamepad support for this game. It just provides much more fine-grained control over the movement and other actions that are tied to directions. But currently, we're stuck with 8 possibilities on the keyboard, which are represented here on the unit circle. Here is when we only press right, here only press up, and here when we press right and up at the same time. So when we look at input.getVector, we only get 8 possible different values. And this just doesn't leave a lot of choice for the player. Shots will either be very predictable or they'll just miss by quite a bit. So there are multiple ways to solve this problem, and I'm going to go forward with a pretty straightforward approach here. So while the player is preparing to shoot, we'll be looking at the keys being pressed. And while the soccer player won't be moving, we'll still be persisting the input as a way to figure out where the player is aiming to shoot. When the shoot key is released, we'll just simply average all of those inputs to figure out the direction that the ball should go. For example here, let's say that I'm moving forward towards the top right and I start pressing the shoot key. And I have those top right, up and right keys and leave pressed for 0.2 seconds. This is the input vector, which is coming out of this. And then I'm going to stop pressing the up key and just keep the right key pressed for 0.1 second. So once I'm done and I release the shot key, I will now have a combination of 2 vectors for some amount of time, and I want to calculate the average between those 2 vectors using weights that correspond to the time spent in that configuration. So in this specific example, I am spending 2/3 of the time in this upright direction and 1/3 of the time in the right direction. So my resulting vector using weights, and we're going to open up a side window here to just do a little bit of math, is going to look like this. So 2/3 of the time times my upright vector plus 1/3 of the time times my right vector. So we can quickly do the math here, and this equals this resulting vector. Now remember that when we work in Godot and we want to multiply this vector by the power, which we calculated earlier, we always want that vector to be normalized. And so just as a quick refresher, normalizing a vector is a single line in Godot. It's a very simple command. But just to make sure that we're all aligned, it just means that we need to multiply this vector. We need to divide it, by the vector's magnitude. So we can find the magnitude of the vector by doing a square root of the sum of the 2 components x and y. And once we have figured out that magnitude, so this is the product here, we can just divide our original vector by the magnitude here. And this will give us the final resulting directional vector, which is fully normalized. And then we'll be multiplying this by our power, and this will provide us with the perfect direction and power for our ball. All right, great. So let's go ahead and implement this in Godot and see how that works. All right, so let's go ahead and start by creating our 2 states. We'll add them to the animation to start with, hop over into the player script, and after recovering, we'll add prepping, shot, and shooting. Then I'm going to go ahead and create the 2 skeleton classes for the 2 states. So file, new script, bring this in the middle. Let's make sure that we are located in the character state. And here I'm going to add the first one, player state, prepping shot. Let's give this a class name. Just going to keep those empty for now. We'll fill those after. And let's create one last script for the shooting state. Player state shooting. All right, and then the next reflex we should have is to add these 2 states to the player state factory. That way we'll always have reference to them. So one of them is prepping shot. And the last one is shooting. Once again, I do like to have those sort of keys and variable names in alphabetical order, but it's absolutely not mandatory. All right, so now that we have our states ready to go, let's start working on the prepping shot. We'll implement what we just talked about in just a few minutes ago. So the first thing we'll need to do is what happens when we enter into that state. So inside the enter tree, this is when the node enters the scene. We'll want to first play the proper animation. And we'll also want to halt the player, make sure that the player cannot move anymore. Okay, this will mean that they'll be more sensitive to being tackled. All right, and then let's hop over into the process and think through what we want to do here. So basically, we enter this state when we start pressing the shot key, and we should leave the state when we release the shot key. So let's look at the release action. Is action just released? All right, so what happens when we release the key? Well, we need to know, first of all, how long we have been in this state, how long the player has been pressing the shot key. So for that, we need to keep track of time, and let me go ahead and create a small variable at the top. Start shot, and we'll just initialize it with the current timestamp to start with. But when we enter the tree is when we want to actually set the value. Once again, I think we can actually get by without this line, because by the time that we create this class, we just add it to the node tree right after. So the difference between this time here and this time is going to be extremely minimal. Anyways, I think this is just best practice, so feel free to remove it and try it out. So once we have released the shot key, we want to figure out how long has been spent in that state. Now, we don't necessarily need to care if the player has been pushing that key for 30 seconds. We probably want to clamp it to some higher value. And as soon as it reaches that higher value, then there's no more bonus added. So maybe let's create a const at the top here. We'll call that duration max bonus. And let's set that to 1 second to start with. All right, so let's figure out how long we have been waiting inside this state. Duration, press, and so here we're going to clamp. Let's do the delta between the current timestamp and the time start shot. We're going to clamp this between 0 and duration max bonus. Okay, so it doesn't matter if you've been pressing the key for 10 seconds, it's always going to limit it to 1 second here. So that value here can only go between 0 and 1 second. And we're just going to be adding, using this to figure out what the bonus should be. So here, if you remember, we then need to figure out in the easing function how far off we are on the horizontal axis. That is kind of the progress of the easing function. And basically, we are going to be dividing this by this. And as we reach towards 1 second, meaning that we've reached the upper top right corner of that curve. So far is time. This is a good enough name. Duration press divided by duration max bonus. Okay, and then now we can actually calculate our bonus using the easing functions. And here we will have our ease time as the first argument. And then the second one is we need to have the ease factor. So I think we mentioned we were going to be using 2.0, but we should definitely play around with various values here. So ease reward factor, let's start with 2.0. All right, so now that we have this bonus, we can now calculate the shot power. And this is going to be equal to the player's power times 1 plus bonus. I don't think we have actually created a power stat, power property for our player. So let's go ahead and hop over into the player script. And right above our speed exported property, let's go ahead and add a power property. By default, I'm going to set this to 70 to start with. Not sure why the speed got reset here. I believe that was 80. Okay, so back into the prepping here, we can now start focusing on the shot direction. So if you recall, what we want to do for the shot direction is every single tick, we want to figure out what the input vector is, and then we'll use the time allocated to have weights on this. So we're going to create another variable to keep track of the current direction. And every single tick, which is going to add to that directional vector our inputs, key utils.get input vector of our player.control scheme. And we should multiply this by delta. Okay, so this is our weight, the amount of time times the input vector. And once we have completed pressing the key, so here, we'll want to normalize this vector. Okay, and let's go ahead and print out both of those variables, shot direction. Okay, so let me pause here for a second just to make sure that everything is clear. So basically, we enter the state when we start pressing the key. While the state exists inside as part of the player node, we then go over this process every single tick. During that time, while we have the shot key pressed, we can continue to modify the directional keys, up, down, left, right, and we're going to be looking at the input vector that this generates multiplied by this amount of time that has been spent since the last tick. So basically, this weighs, from the time perspective, the various controls that the player is putting. And we are going to have a shot direction that is a vector that continues to grow over time, but it grows more towards the directions that we are pressing. So at the end of the day, once we stop pressing the shot key, we'll go ahead and normalize it to have kind of a vector of length 1. And in terms of power, we're going to be using the easing function, figuring out where on that curve we are, and then adding that as a bonus to our player's power. So now we need to think quickly about how do we transition into the shot prep state. So we should only allow the character to shoot when they have the ball. So that means we should check whether the ball's carrier's property is the current player. So let's... So I think every single soccer player object will always need to be aware of the ball throughout their life cycles. Like the players will need to look at the ball, they'll need to go towards the ball, they'll need to figure out what to do depending on where the ball is. So we should probably have a direct reference as part of the player. And let's go ahead and export this value and hop over into the world. Let's pick our 3 players and let's just set the ball property right away. We'll just set it to the ball that's here. I bring this to the middle. All right, that way those 3 players are properly set. And back in the player code, we are going to maybe add a utility function here just to check if we currently have the ball. And what we'll do is we'll return the ball.carrier and check if it is the current player. This always exists, by the way, but it can also be null. So now let's hop over into the moving state, and this is where we're going to have a transition into the prepping shot key. Let me actually remove this for now. I'm just going to comment it out so we can just focus on shooting. So if a player has the ball and key utils.is action just pressed, player.control scheme. And here we're interested in the shot, the shoot action. Then we will transition over to the prepping shot. So state transition requested.emit player.state.prepping shot. All right, so let's try this out. So when I hop over and take the ball, I'm going to press the I'm going to move this real quick so we can see the output here. And I'm going to be pressing the shot key. We should transition over to the prepping shot. As you can see, this is the case. I'm leaving the key, but I'm moving my directional keys as well. So now that I'm done, I have a intensity, a shot power of 140 because I left the key pressed for more than a second. And then this is a random vector that just corresponds to the various directions that I pressed. I pressed more towards the left-hand side, and you can see that this vector is kind of geared towards the left. So this seems to be working really well. However, without some form of visual feedback, like we actually need to see the ball go and fly in that direction, it's a little bit hard to know whether this is working properly or not. But looking at the time, I feel like this might be a good time to create a quick checkpoint and call it an episode, because there's still a few states that will need to be implemented before the results can actually be visually appealing. So we'll need to fix the player kick state, and then we'll need to implement the ball shot state as well. So like usual, let's go ahead and create a quick checkpoint as part of our Git. Added prep shot state. All right, I kind of wish we had moved a little bit faster today, but I didn't want to skim too fast over the shooting mechanic, given how critical it was to the game. So, that being said, using easing functions and other types of interpolation is just super useful to make dynamic movement and behavior. So, hopefully this is something that you take away as something that you can actually easily use down the line for every one of your games. Now, we're starting to get pretty deep in code, so please don't hesitate to ask any questions in the comments below. I hope that throughout this tutorial, you never have to write a single line of code that you don't fully understand. A big thank you for making it this far in this series. The game is, slowly starting to take shape, just a little piece at a time. Hopefully you're learning new things, and if you do appreciate my work, please do consider telling my friends over at YouTube by pressing the like and subscribe buttons. And once I reach 1,000 YouTube subscribers, I'll have you pick the nature of the next tutorial series. All right, time to take a quick break, and I'll see you in the next episode. Cheers.